Your computer just failed a test a 5-year-old aced. You stare at blurry fire hydrants and the machine still doubts you. A computer crunching billions of calculations per second got stumped by a smudgy crosswalk photo. Think of a train gliding down a track. Every wheel, every turn, perfectly predictable. That is exactly how software operates all day. Computers dominate almost everything they touch. They beat chess grandmasters, land rockets on ocean platforms, and process your taxes in seconds flat. But show one of them a blurry photo grid, and they freeze. A machine that cracks encryption cannot identify a plain fire hydrant, and it keeps happening every single time. The test updates, computers struggle again, same pattern repeats across millions of different websites worldwide. So what is really going on here? Why does something this simple completely break one of the most powerful tools humanity has built? Look closer, and something really does not match at all. The test is not checking whether you click the correct box answer. The system already decided before you touched the mouse. It was watching how you moved, where you paused, and what your browser held. Your mouse path is actually a biological signature. A bot travels in a perfectly straight mathematical line at constant, unwavering robotic speed. Your hand drifts left, self-corrects, slows near the target, then accelerates into the final click. No bot ever replicates that naturally. Engineers call these tiny inconsistencies a behavioral fingerprint. They come from real muscle and nerve response, nearly impossible to replicate at scale. Before your cursor moves, the system silently reads your browser cookies, your history, and exactly how long you have been on page. A bot arrives completely clean. Zero history, no cookies, no time browsing. That suspiciously perfect blank profile raises every automated red flag. The system actually hunts for imperfection, hesitation, drift, digital messiness, as confirmation that a real human being is present here. Think of a TSA officer at O'Hare watching passengers board. She is not just scanning tickets, she is reading behavior the whole time. Your wandering, trembling cursor is more trusted than any password you have ever set. The chaos is the credential. Imperfection proves humanity. This pattern is too consistent to ignore. Human imperfection is the actual signal, not the noise. But here is the next important question. What happens when bots learn to shake? If algorithms fake a trembling hand, does the image grid become the very last real defense? Computers do not see images like you do. They process a flat grid of numbers, color values assigned to each pixel. No object, no meaning, just math. A stop sign is a red rectangle with white numbers surrounded by other numbers. Nothing more exists. You see that stop sign and know it belongs at an intersection, not floating in a kitchen. Machines call that ability semantic understanding. Shadows expose the gap perfectly. A rain-soaked traffic light half hidden behind a wet oak tree in Seattle is instantly obvious to you. MIT researchers in 2019 found that leading vision models lost 40% accuracy when objects were partially blocked or lit poorly. CAPTCHA designers exploit this on purpose. They deliberately pick images with odd angles and partial views, exactly where machine recognition collapses fastest. Training data makes the problem worse. AI only knows what it trained on. One unfamiliar sticker on a stop sign breaks the model. No existing model fully bridges pixel recognition and real-world context. That gap is precisely where every image-based CAPTCHA is designed to operate. Different engineers describe this differently. Some call it pure security. Others say something far more interesting is happening at the very same time. No single explanation covers the data. Every time you solve one of these puzzles, someone else is getting real value from your answer. The official version is straightforward. CAPTCHAs block bots from flooding websites, crashing servers, and registering fake accounts by millions every single hour. That is completely real. Without them, automated scripts would drain concert ticket inventories in seconds and turn every comment section into relentless spam. In 2007, Luis von Ahn, CAPTCHA's own inventor, launched a follow-up called reCAPTCHA. And it changed absolutely everything. Every distorted word you typed was one book scanners could not read. You digitized New York Times archives, completely unpaid, totally without knowing. Image grids work identically. Every time you click school buses and crosswalks, you label training data for self-driving vehicle perception systems. Free. Both models are true, and together they create a paradox. Teaching AI to spot crosswalks makes it incrementally better at defeating the test. Neither explanation resolves the loop. Better AI demands a harder CAPTCHAs, which means sourcing data the AI has never been exposed to yet. The barrier and the classroom turn out to be one room. The test, designed to stop machines, is also the engine powering them. Go back to that first moment. Coffee, ticket site, tiny checkbox. That box is not a gate anymore. It is a treadmill. Every click teaches the machine. Every solved puzzle narrows the gap. The student keeps catching up fast. What replaces this, nobody knows.